Have you ever heard of butterfly or bow tie rule in circle geometry? This is actually a secret visual trick to mastering one of the easiest and common theorems you will face in your WAEC exam, your NECO exam, your JAMB exam, and any other college exam. Welcome to Post Scholars channel. Hope you are having a great day. Now let's dive in. You see, the title of this video is Angles in the Same Segment, and there are two questions we are going to solve, right? Before we can solve these questions, we need to understand the theorem called angle in the same segment. Now, if you want to know more about all theorems guiding circle geometry, do well to watch my video. I've done a particular video on circle geometry theorems, so you can watch it. It's among the playlist titled Euclidean Geometry, right? Okay, now I said something that there is a rule called the bow tie or butterfly rule. How does a bow tie looks like? Now, this is how a typical bow tie looks like. You agree with me? Something like this and something like this. Is that not so? Now this is a bow tie. Now, if this bow tie is inserted in a circle, for example, let's complete the circle. This is the complete circle. Don't worry, this is not an actual circle, but I'm just trying to make an illustration. Now the theorem is saying this angle, right, is equal to this angle. You can see that this angle is touching the edge of the circle, and this angle is also touching the edge of the circle. The theorem is saying this angle and this angle is equal, provided both angles are sharing the same chord. Let's insert the chord. This is a chord, right? A chord is any line joining 2 points in a circle that is not a diameter. So this is a chord. You can see this angle, right, is sharing this chord. Watch, this is the angle, is sharing this chord, right, and this arc. Similarly, this angle to watch is also sharing this chord, so that makes this angle and this angle what equal, right? So I believe you should be able to identify this pattern in any circle geometry problem. Now let's solve this question. We are asked to find letter A, letter B, and letter C. Now let's do this together. You must be very smart and sharp to identify the theorem guiding the circle geometry problem. Now look at angle A, right? Where is the chord? Let's draw an imaginary chord, right? This is a chord, this is a chord, right? Good. Now we have drawn the chord. Now let's check. This angle A is sharing this chord, right? Is associated with this chord, right? Look at angle 40. Remember, both are touching this circumference. Look at angle 40. Angle 40 is also associated with this chord. You can see it simply means angle A is equals to angle what? 40. That means A is equal to 40 degree. So you write it confidently. A is equal to 40 degree. Then you write your reason in case it's a theory exam. Angle in same segment. Next, we have to find angle B, right? Now you check. Look at this angle, right? Is on the circumference. There's no problem. Now let's check whether it's associated with this chord. Now let's go. This is the first line. Remember, two lines usually make, when two lines meet, right, it makes an angle. So this is the line, good, and this is the other line of the angle, good. You can see it's associated with this chord. Since it's associated with this chord and this angle is also associated with this chord, we can say B is equal to what? 40 degree. So write it. B is also equal to 40 degree. And what's the reason? Angle in same segment too. Now the reason why we say same segment, because look at this chord, right? This chord has divided this circle into a major segment and a minor segment. You can see these angles, they are in the major segment, right? What's the next angle we need to find? Angle C. Now we need to be careful with this one. Now where's the angle? Watch, this is angle what? This is angle C, associated with this circumference, right? So let's draw the chord associated with this angle C. Now the chord associated with this angle C is something like this, right? An imaginary chord. Good. Now this is the chord associated with angle C. You can see this is the line and this is another line of angle C, right? So this is the chord associated with angle C. Now if you check 32 degree, you see that the angle at this circumference is also associated with this chord. You can see it. This angle and this angle are sharing, are on the same chord. So I can safely say that C, and watch, you can see a bow tie. You can see bow tie. You can see a pattern of a bow tie, right? So I can safely say angle C is equals to what? 32 degree. So C is equal to 32 degree. And what's the reason? Angle in same segment also, right? Now we are done with question 1. Now let's move on to question 2. Great, here is question 2, right? Now we are asked to find the value of angle E, angle D. We are asked to find the value of angle E and angle D. Now, without wasting much time, now let's check. This is angle D. We need to identify and always look for a bow tie. You can see this is a bow tie, right? So look, this is angle D. Where is the chord associated with angle D? You can see it. This is the chord from here to here. You can see it. This is the chord associated with angle D. Now let's check. This is 115 degree. Where is the chord that this angle 150 is sitting on? Look at it. It's also this chord. That means I can say angle D is equal to what? 115 degree safely. And what's the reason? Angle in same segment, right? Next, we have to find angle E. Now, you see that angle E is actually not on the same segment with 115. So E cannot be 115. Okay, let's confirm. This is angle E. Where is the chord associated with angle E? You see, this is the chord associated with what? Angle E. Where is the chord associated with 115 degree? This is the chord. So they are not on the same chord. So I cannot say angle E is equals to what? 115 degree. But then there's a theorem called angle in a semicircle, right? Angle in a what? Semicircle. Please, if you have not watched my video on circle geometry theorem, go there now and watch it. And if you're actually enjoying this video, please just subscribe, like and comment. This will actually encourage me to keep pushing. Thank you very much. Now there's a theorem called angle in a semicircle. You can see this is semicircle, right? And this is the angle associated with the semicircle, right? This is a diameter. A diameter bisects a circle into two. So this is the line bisecting the circle. Definitely this angle is the angle in the semicircle, right? One is going to one end of diameter and one line is also going to another end of diameter. So E is equals to what? 90 degree. It's a theorem, right? It's a theorem. So I'll just say E is equal to what? 90 degree. And what's the reason? Angle in a semicircle. Now we have come to the end of this video. So whenever you see a pattern looking like a bow tie, right, just know that you are talking about what? Angle in the same segment. I hope it is well understood. Do well to watch my next video. God bless you and bye.